Hello everyone and welcome back to Geminic Science. In this tutorial we're diving into the fascinating world of physics, which is the inclined forces. Have you ever wondered how objects move on a sloped surface? Let's break it down with a simple problem and solve it step by step. Let's assume we're given this kind of problem which says a 10 kg box is placed on a smooth 30-degree inclined plane and you're asked to calculate the parallel component, which is force causing the motion down the plane. And secondly, you're asked to calculate the normal force, which is the force exerted by the plane on the box. And we need to assume the acceleration due to gravity is 9.8 meters per second. How can we solve this problem? First and first, there are things which you really need to understand before you approach this kind of problem, which is the force of an angled surfaces. We have things like the weight force, the normal force, the frictional force, the perpendicular force, and we have the parallel forces. So let's start by drawing our angle 90 degree, which is the right angle triangle. You see here we have theta, and normally our object used to be placed here. So the normal force will be drawn this side, but let's start with the weight force. The weight force, this is simply the longest vector straight down, and it's been denoted by Fw. This is what we call the weight force. Some diagrams may use different variables like Fg or mg, that is in place of Fw. So where can we place this, what do you call it, weight force? Weight force is the one pulling downward this side, which we can write as Fw. So another thing which we have, or second thing which we have, is what we call the normal force. And notice that the normal force is simply the reaction to the force pushing into the heel. And the normal force is being denoted by Fn. And on this diagram, we can put the normal force as Fn this side. So next thing which we have is what we call the frictional force. Notice that the frictional force is simply the force of friction reaction to the forces pushing downward the heel. We can place our frictional force, which is F, capital letter F and a small letter f that side. So next thing which we have is what we call the perpendicular force. And notice that this line, we can call it to be our parallel, and perpendicular has to be something this way. So the perpendicular force, in some textbook, they represent it as F with capital letter T downward. And notice that the perpendicular force is simply the force which is pushing into the heel. So in this case, we can call this to be our perpendicular force, which is F underscore T. So the only thing which we're going to be left with is, let's increase the size of this. And this side is going to close up. And we have the parallel force. So therefore, this side is going to be our parallel force. And the symbol which we use, and notice that the parallel force is simply the force which is pushing down the hill. And we can represent the parallel force by F with these two double lines. So let's begin by solving this problem. Notice that on the inclined plane, the weight of the object has two components, which is the parallel forces and then the perpendicular forces. And we said the parallel forces is simply the one that pull the object down along the inclined plane. And the perpendicular, it simply acts into the plane, counteracted by the normal forces. So in this case, we're going to start by picking the data in this problem. The first thing we are given is the mass of the object, which is 10 kg. and we are given angle of theta, which is going to be 30 degrees. So let's start by calculating each and every component. The first component which we are going to solve is the parallel component, which is denoted by this symbol, that is this component. And in this case, before then, we need to calculate the weight of the object. Notice that the weight which is being denoted by W is going to be the mass multiplied by the gravity. And our weight, the mass, is going to be 10 kg multiplied by the constant gravity, which is going to be 9.8 meters per second. So our weight is simply going to be 49 newtons. Sorry, if you punch on your calculator, it's going to be 98 newtons instead. So, second thing we need to do is to calculate the component. So calculating the component, we're going to start with the parallel component, which is F with this double line. So notice that this is going to be, our parallel component is going to be W sine theta, which our W is going to be our 98 in newtons multiplied by sine theta. So this is going to be 98 multiplied by sine. What is the value of theta? Notice that the value of theta is going to be 30 degrees. If you punch on your calculator, sine 30 degrees is simply going to be 0.5. 0.5 multiplied by 98, and this is simply going to be 49 newtons. Second thing we need to calculate is the normal force, which is being denoted by Ft. Notice that this is simply going to be W cos theta. And the value of our W, which is the weight, is going to be 98 in newtons multiplied by cos 30 degrees. Cos 30 degrees on your calculator is simply going to be 0.866. 0.866, if you multiply that by 98, is simply going to give you this value, which is 84.9 newtons. So this is the parallel force causing the motion, which is 49 newton, and here we have the normal forces, which is the reaction by the plane, which is going to be 84.9 newtons. So this is it for this problem. I hope you find it helpful. If you do, please just do me a favor by subscribing to Gemnex Science. Thank you for watching, and see you next time. Hello